Hi everyone, my name's Kyle, and this is Grade 10 Chemistry Lesson 2, Ionic and Covalent Compounds. So hopefully you watched the first lesson and you're on to this one next, but if you haven't, go watch the first one because that's very important for this video. So we're going to go over not again, but two main things. So it's going to be how to name and write ionic compounds that have polyatomics, and also how to name and write covalent compounds. So down here, we're going to be using this new sort of discover elements. Now I don't know how they got there, my teacher. And we're going to be using these for the examples only, and I don't know why. It's just like that's why I have to do it for this presentation. I don't know why. That's just how things done. It's because of my teacher. Anyways, so going back, hopefully you're gonna know like what these prefixes mean, and also this sort of like format in the in naming ionic compounds. So, let's get started. So, before we start, there is one thing, and this is for ionic compounds that have transition metals or any sort of metal with more than one charge. So, when naming ionic compounds, you always want to specify the charge, or the charge of the transition, or other metal with more than one charge in Roman numerals. So, as I was saying, like with the examples in that new periodic table, we have Efexium 3, quinine. I'm not trying to say that, but yeah. So the 3 in Roman numerals means that the specific charge of the atom. So this is the charge of Efexium. It's specifying it. So since Efexium can have a charge of +3 and +5, or +5, you must specify which charge in Roman numerals so the charge is balanced. So over here we have the charge of Efexium, and Efexium has a charge of +3 or +5, and since we wanted to have a charge of +3, it'd be +3, and then since quinine has a charge of -3, 3 minus 3 is 0, and they're perfectly balanced. So they cancel each other out. So as you can see here, a little meme. And also this is Roman numerals, so if you didn't know already, definitely learn all of these because those are, they're pretty important. You might have seen them in the games, but yeah, those are the Roman numerals up to 10. Now, we're going to talk about how to name and write ionic compounds without polyatomics first, and it is mainly because it's a pretty long explanation. So, to name ionic compounds without polyatomic ions, you first want to say name, so when you're naming it, you want to say the metal and the non-metal, and then with the prefix, with the word "ide" at the end of it. Now, it's kind of weird with the actual elements, like down here, oxide, you're not really replacing the last 3 letters with "ide." It's more like the last couple letters, but you're probably going to find it through your teacher. Anyway, so this is the example. So we have Efexium quinide. So I showed you this before, but the IDE ending, that's really important. So, so for the formula, so now we're going to talk about the formula. So in the writing part. So first, you want to find out the charges of the metal and non-metal, and then see how many of each of those atoms you need for the charges to equal 0. So, for example, we had the Efexium over there. So an Efexium, and Efexium can have a charge of +3, and quinine has a charge of -3. So 3 minus 3 is 0. So now you want to write the symbols of each element with a subscript of how many atoms there are to make the charges balance. Unless, I'll try to delete it, but unless you do not need to, unless there is more than one. If there's not more than one, you don't have to put the subscript. So down here, you wouldn't need this if it's just Jamesanide, just by itself. You wouldn't need to add this 3. Anyway, so this is the example that we have. So we have provanedium, 3, Jamesanide. So the 3, as we said before, it specifies what charge it is. So provium has a charge of +3, and since there's 2, so over here, we'll specify the charge. Jamesanide has a charge of -2, and so since we had 2, providum has a charge of +6, and then the Jamesanide, these elements, sorry, and this you need 3 of the Jamesanide to make it -6, and then 6 minus 6 equals 0. Cancel out. Everyone's happy. So now this is going to be about how to name and write ionic compounds with polyatomic ions. So in order to write one with just one polyatomic, we're gonna talk about like with just one, and if there's multiple. So if it's just one, when you're actually just like naming it, you just write the name and the polyatomic ion. This applies for if there's more than one too. You just name the metal and then the polyatomic. That's it for naming it. Now for the formula, it's basically the same too. You just want to put the symbol of the name and the symbol of the polyatomic. So, or if we have a helium, and this is one of our metals, and this is Jamesonite, which was one of our polyatomics. So as we see here, it's just AH and then the polyatomics symbol, which is JMO4, and yeah, that's it for that. But now, if there's multiple, this is where it gets pretty complicated. So I just bear with me a little bit here. So in order to do that, you might for the name, the name is, as I said before, the name is the same thing, but for the formula, you want to take the metal and then put the polyatomic in brackets. So the bracket, polyatomic, then end bracket, and then the subscript. So down here you can kind of see it. We'll get to that. So with the amount of polyatomics needed to balance charges. So we have a helium down here. So helium 4 and quinite. So helium, so that's 4 times 3, that's 12. So this would have a charge of plus 12. And then in order for this to balance, quinite we need to have a charge of minus 12. I have a charge of minus 12. And in order for it to have a charge of minus 12, it would need to have 4 of them. So I have to have 4 because quinium has a charge of plus 3. Charge of plus 3. I want to say has a charge of plus 3. Has a has a charge of minus 3. Sorry, has a charge. So quinite has a charge of minus 3, and since there's 4 of them, 3 times 4, that's 12. And yeah, well, minus 12. Sorry, minus 12, and then we have the 12 minus 12 equals 0. So these two are happy. So now we're going to get to our last sort of topic, and it's going to be how to name and write covalent compounds. So for covalent compounds, you have to use certain prefixes for the two nonmetals to show how many elements are in each. So depending on how many atoms, you're going to use prefixes. So down here, as I said, you have to use these prefixes and show how many atoms are in each. So yeah, so this doesn't apply to the first element, however. So like for example here, you're not going to say mono over here because it's just one. And also, you won't have to put the IDE at the end of this too. It's only for this last part. Only the last nonmetal will have the IDE at the end. So only here, not this nonmetal. So another example of using these prefixes for the for actual naming it, you have down here. So JM, so this is Jamesonite and Gibsonite. You get the point. And since there's 3 of these, we're going to look for the prefix for 3, so tri. So I put tri Jamesagon, and then since there's 6 of the Gibsonite, you find 6 hexa, so that's tri Jamesagon hexa Gibsonite. Okay, so yeah, so hopefully you can apply that to the actual periodic table. I'm sorry, it definitely seems it's going to be really confusing without using the actual periodic table, but hopefully you understand from just that. And that sort of gives you like a surface level understanding, and that should be enough for your next test. So anyways, that's going to be it for today's video. There won't be any more for a while, so if you want me to make a new video or explain this in a better way with actual period elements, I can do that. But yeah, that's going to be it. So thank you for watching, and yeah, that's it.